8.3, the sum of interior angles in a polygon. What we do to figure these out is we try and draw triangles within shapes. So the first shape we have is a triangle, which clearly consists of one triangle. But if we pick a point in the square and we join the opposite corner up with it, what we can see is that a square is made up of two triangles. Now we know the angles inside the first triangle will add up to 180. We know the same is true for the second. So then that's why we know that the angles inside a quadrilateral will add up to 360 degrees. And that'll work for any quadrilateral that we were to draw. If we look at this pentagon and then pick a point, and if we join up the opposite corners, we can see that we've now formed three triangles. And each triangle adds to 180 degrees, or the angles within it add up to 180 degrees. So that means the sum of the angles of a pentagon are 540 degrees. A hexagon, again, we can do this for any hexagon, is to pick a point and join up the corners opposite it. And what we can see for this hexagon is that we've formed four triangles. Each angles then within each triangle will also add up to 180 degrees. So that means that all the angles within the hexagon, we've got four lots of 180, so that's 720 degrees. And for a heptagon, same idea again, pick a point and join up opposite corners. And what we can see is that there will be five triangles formed, each of which the angles will add up to 180. So then the angles in a heptagon add up to 900 degrees. So having done that, we can now fill in this table. So a quadrilateral, a four-sided shape, had two triangles and the angles added up to 360 degrees. For five sides, we found three triangles and that was 540 degrees. A hexagon had four triangles and the angles added up to 720 degrees. Heptagon had five and that was 900 degrees. And we didn't do an octagon, but hopefully we can see that it would be six triangles and a total of 1080 degrees. So what we'll notice, or what you may notice, is that to get from the number of sides to the number of triangles, to get from 4 to 2, from 5 to 3, 6 to 4, 7 to 5 and 8 to 6, what we're doing each time is timesing by 2, or taking away 2. And then to get from the number of triangles to the sum of the interior angle, what we're doing is we're multiplying by 180 degrees to get from the number of triangles to the sum. So what we have is a formula then. So if we had n sides, where n is just the number of any sides it could be, what we do is we take away 2 to find the number of triangles, and then those triangles all will add up to 180 degrees. So we have to multiply that number by 180 degrees, and that will equal the angle sum, or the sum of the interior angles. So here it is formally. So the sum of the interior angles of an n-sided polygon is n minus 2 times 180. So what we mean by that is if we had a, let's say, 12-sided shape, a dodecagon, so if n equals 12, we're going to have the sum of the interior angles is going to be 12, take away 2, multiplied by 180, which is 10 multiplied by 180, so that's 1800 degrees. So find the sum of the interior angles for an 11-sided polygon. So what that means is n equals 11. So we're going to have n minus 2 times 180 is the formula for the sum of the interior angles. So that's 11 minus 2 times 180, which is 9 times 180 degrees, which is 1620 degrees. Example 5, find the angles of marked A and B. So A, first of all, well, we can see that A and 155, that's the interior and the exterior. and we know they add up to 180, so to get the exterior, that's 180 minus the interior, which is 180 minus 155, which is 25 degrees. So A equals 25 degrees. Now to get what B is, we need to work out, first of all, what is the type of polygon. And we can see there are 5 sides, so it's a pentagon. Now all the angles marked are interior angles. So the 65, the 125, the 155, the 140 and the B are interior angles. So what we know about the interior angles is the interior sum is n minus 2 times 180. So in this case it's 5 minus 2 times 180, which is 3 times 180, which is 540 degrees. Now if we add up the angles that are marked, so 65, 125, 155 and 140, we get 485 degrees. So to work out B is going to be 540 minus 485, which is 55 degrees. Example 6, a regular polygon has an exterior angle of 36. How many sides has the polygon? So what we know for this is the exterior angle is going to be 360 divided by the number of sides, or we could say that the number of sides is 360 divided by the exterior angle. Because what we know is if we've got 10 and that equals 50 divided by 5, then we could say that 5 is equal to 50 over 10. So we can swap these two terms about, and that's fine. So we can swap the 10 and 5 about, and it's going to be true. So similarly, we can do the same for the n and the exterior sides. So we're trying to find the number of sides. So that's going to be 360 divided by the exterior angle, which is 36. So that means it's going to be a 10-sided shape, or a decagon. Part B, what is the size of each interior angle? Well, we've just worked out that the exterior angle was 36 degrees, and we know that the interior plus the exterior add up to 180 degrees. So to find the interior angle, we do 180 degrees minus the exterior. So that's going to be 180 minus 36, which is 144 degrees. So remember, if we've got the angles, the exterior we've worked out is 36, so they lie in a straight line, so the interior must be 144. Example C, explain why a regular polygon can't have an exterior angle of 25. For this, it's actually easier to assume that it is true. So if we assumed that it was true, to work out the number of sides, we'd do 360 divided by the exterior angle. So let's see how many sides this would have. So we do 360 divided by 25, and we get 14.4 sides. Now that is impossible, because we can only have a 14 sides or 15 sides. We can't have 0.4 of a side. So if we do this calculation and we get a number that isn't a whole number, then we know that it's not possible. And another word for a whole number is an integer. So the answer here must be an integer.